Hi, welcome back to Bird's Myth Busting series. I'm Russ Buttress, an application engineer here at Bird. I'm joined by Tim Holt, our consulting technologist. Today we're covering the myth that wattmeters can only measure one signal type. So Tim, where does this myth come from, and why is it not true today?
Well, I'm glad you asked that question, Russ. So the reason for that is lost in history. And let me start by introducing the Model 43 power meter. This instrument was introduced by Ray Bird at the Institute of Radio Engineers conference in New York City in 1952. This is the first inline directional power meter that was introduced for use in general communication systems. This is a later model of the same instrument that you might actually recognize. There are some characteristics of these power meters that are universal, these conventional RF power meters. First of all, they were made to handle the simple analog modulation types that were in place at the time, mainly AM and FM systems. Whether it's in broadcast or two-way radio, those were the main modulation formats. And again, modulation, just to refresh your memories, is the process by which intelligence, whether it's voice or data, is encoded on a radio carrier. And back in those days, it was primarily voice. Again, simple analog modulation, AM and FM, primarily in use at the time. And these power meters used very simple diode detectors that were just available at that time, just beginning to be available at that time, in order to extract average power information about the signals that they were measuring. And as time went on and more complex waveforms were introduced, and I'll introduce what's meant by complex waveforms in a minute, but as these more complex waveforms were introduced and data was the real subject of what was being passed on the radio carrier as time went on, as more and more data was passed on the radio carriers, these instruments began to make incorrect measurements of these systems.
Well, that explains where the myth comes from. So how is the 4480A able to measure both complex and simple modulations in the same device?
Great question, Russ. And the answer to that question really is related to the types of diode detectors that are used in the 4480A. When we realized that we wanted to make develop one instrument for the measurement of just about any type of waveform, any type of modulation format that was out there, we knew that we needed to use more complex diode detectors, detector schemes that were able to measure the average power of just about any waveform. And because again, we were moving away from AM and FM systems that were traditional. Again, the movement of data across the radio channel required more complex formats, and these formats involve the combination of amplitude, phase, and frequency modulation, often in the same system. As you can see here, I've drawn an unmodulated waveform, a continuous wave signal, and then this waveform down here, as you can see, has these ridiculous peaks in the amplitude that the instrument must process. And the diode detectors we use in the 4480A are designed to do that.
Okay, so we have better diode detectors that are more versatile. Why is that so important?
And you said the word, Russ. The word is versatility. Users that are in the field making measurements don't want to have to choose a different power meter in order to measure different systems. So if they're measuring analog systems, that maybe they would use this instrument, but it's best to have one instrument that could handle both, and that's where the 4480 shines.
Oh, that's great. There you have it. Myth busted. The 4480A is capable of handling both simple and complex modulations all in one device. If you'd like to learn more, please visit our website at birdrf.com. Thank you very much, Tim. Thank you for joining us.